In problem number 22, we need to calculate the distance traveled by a car that travels with constant acceleration and accelerating from 0 to 80 miles per hour in half a minute. Now you may remember the familiar formula which we use to calculate the distance traveled by an object, namely distance equals speed times time of travel. The important thing to realize is that this formula can be used to calculate the distance traveled when the speed is constant. So for example, if you're driving on a freeway at a constant speed on cruise control at 75 miles per hour, you're traveling for, let's say, an hour or and a half, then you can calculate the distance traveled by taking your speed of 75 miles per hour and multiplying it by 1.5. Now, however, if the speed is not constant, if it varies from with time, if sometimes you drive fast, sometimes you drive slow, then you can't use that formula to calculate the distance traveled for various reasons. One of them being that what value would you use for speed if it's not the same at different moments of time. In case when the speed is not constant and varies with time, we can use integration to calculate the distance traveled. So the formula that we use in this case is distance equals definite integral of the speed, integrate the function that describes how speed varies with time, integrate the speed with respect to time over the time interval from A to B if we need to calculate the distance traveled on that time interval from t equals to A to t equals to B. Okay, so this is the formula that we will use to calculate the distance traveled by the car in this problem. The first thing that we need to do, though, is to obtain a formula for the speed of the car. Since the car is accelerating, its speed is increasing, and what we need to have is a formula that will tell us what the speed of the car is exactly at the moment of time t. The car is traveling with constant acceleration, and we can calculate that acceleration. So let's first calculate the acceleration. Let's denote it by A, acceleration. It will be equal to 80 miles per hour. That's an increase in speed. The speed goes from 0 miles per hour to 80 miles per hour. That's an increase of 80 miles per hour, divided by the time it took for the car to accelerate from 0 to 80 miles per hour, which is half a minute. But considering that the speed is in miles per hour, we're going to convert half a minute into hours. It's going to be 1/2 times. Now 1 minute is 1/60th of an hour. So we will be dividing 80 by 1/2 multiplied by 1/60 hours. And so what we're going to get then is, well, essentially 80 times 120 miles per hour squared. And that's going to be 9,600 miles per hour squared. The acceleration tells us by how much the speed is increasing. Now, since the acceleration is constant, the velocity or the speed of the car is going to increase steadily at a constant rate, namely given by A, and the graph of the velocity versus time is going to be a straight line. With the slope of this line being equal to A that we just calculated In fact, you will recognize that the formula we used for calculating the acceleration is essentially the formula of taking the rise and dividing it by run. The rise in this case is the increase in speed, 80 miles per hour, and the run is the time interval over which this increase in speed was achieved. So this tells us that the speed of the car, the velocity of the car at the moment of time t, will equal to a times t. In other words, 9600 times t. We assume here that t is in hours. Okay. Once we have this, let's apply the formula that I mentioned earlier, that to calculate the distance, we need to integrate the speed. Let's do that. Now we have a formula for the speed of the car at the moment of time t, and we can integrate that function over the time interval that we're interested in. Okay, so continue here. Distance traveled by the car equals integral from 0 to half a minute, but again we're going to express that half a minute in hours, so it's going to be 1 over 120 of an hour, and we are integrating 9600 t dt. Okay. To calculate the integral, we use the fundamental theorem of calculus. We'll look for the antiderivative of the function that we're integrating, which is easy to find here using the power rule. 9600 multiplied by t squared over 2. This is the antiderivative, and we will plug in the endpoints of the interval of integration, 0 and 1 over 120 for t, and take the difference of those values. Now when we substitute t equals to 0 into this antiderivative, the result is 0. So we only really need to use the upper limit, 1 over 120. And that gives us 9600 times 1 over 2 times 120 squared. Okay, so that's going to be 9600 divided by 2 and by 14400. We can reduce this fraction by 100, so zeros cancel out. 96 can keep reducing. Let's see if I can find some more space here. Yeah. So if I, let's reduce both numerator and denominator by 2 to begin with. So it's 48 divided by 144. Now let's reduce by, let's say, 4, 12 over 36. Now we can see that this simplifies to 1/3. And this is in miles, and therefore we find that the car, during this half a minute, the car traveled 1/3 of a mile.